Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Today bacha I am back with another chapter of your PU1, okay, portions for KCET. Okay, so today we're going to do bacha what? Your trigonometric functions part 1. In this we'll talk about all the formulas. We'll see I've given you the list of the formulas, I've given you the charts. Okay, I'll give you everything in detail bacha, of course. The graphs explain you, I'll tell you the nature of the functions in different quadrants, and we'll talk about basically everything which is there, which is very important for your for your examination from this particular chapter. So this will be a one shot bacha. You're gonna do all the concepts in one session only. Again, I've taken some questions in the session today, and then we will do bacha more questions in the coming sessions. So today only theory and some questions based on these theories to create a bridge. Okay, so I hope you're ready for that. You've been waiting for this particular series for PU1 and I've started it. So here we are on the session number 64, video number 64 bacha, to complete our PU1 part as well. Okay, so chaliye let's go to the introduction of your chapter trigonometric function. What do we have for that bacha introduction part? We define the name, right? Trigonometry. So using the word trigonon and metron. Okay, so trigonon means what? Stands for three angles, and metron means the measure. Okay, so in the beginning, therefore, trigonometry meant the branch of mathematics which dealt with the angles and sides of triangle and various relations existing between them. This is a very important word over here, bacha. Okay, it's not important for your exam point of view, but just for definition's sake. In the beginning, where is it? In the beginning means what happens right now, bacha? In the beginning dealt with a triangles relation only. Okay, that's what we understood it to. But now we can, that we can deal with to find the bacha for certain different identities, certain with respect to, we also use this ratios with respect to your circles. Okay, we use all of that now. Okay, so we are having more applications of trigonometry right now. But in the beginning we used to deal with only the relation to create bacha for right angle triangle, relation between sides to the angles, right? So we have to see what are the different parameters over here. So of course, as the name suggests, we'll have a relation between sides and angles. So we'll learn about how can we relate little bit. Chaliye. So I think you've learned most of these things in your 10th grade, right? When you learn trigonometry for the first time. Okay, first thing is angles. What is angle, bacha? The measure of the rotation. Any rotation that you're taking with respect to a reference plane. A reference plane is very, very important. Very important. Let's make a reference plane over here. So reference plane is like this, sir. Okay. Let's call this plane, bacha, OA. So it's a line. Okay, call it a line. Okay. So line is OA. If you rotate, I can rotate it like this, bacha, or I can rotate it like this, bacha. Both is correct, no? One is called as clockwise, other is called as anti-clockwise or counterclockwise. CCW or CW. We also call this as CW, the clockwise, and counterclockwise is also right. Correct, na? That's the way to write. Okay, so anti-clockwise and counterclockwise is the same thing, and clockwise is the rotation over here that I have mentioned. Okay, so when you do that and you take this line over here till this point, let's say call this to be B. Okay, then this is called as a angle. The measure of rotation, how much you have rotated this point B or this arm from the reference point to the next end. Okay, that is called as the angle. Okay, chaliye. So how do we again take this rotation, bacha? We can take in two format. One is called as clockwise, other is called as anti-clockwise. Whenever we are doing with this type of rotation, whenever we are having this type of rotation, bacha, the counterclockwise rotation, we call the angle to be, angle is positive. Whenever we have dealt with, or when we are dealing with anti-clockwise rotation, we call the angle is positive. Okay, and when we are dealing with bacha clockwise, we say angle is negative. Angle is negative. Is that clear? That's all that matters in this anti-clockwise and clockwise angles. Okay, now next one, measure of an angle. What is the meaning of that? How do we measure the angle, bacha? Of course, the swept region we'll look for. Okay, the swept region. How much is the region swept? Okay, is it area? It's not area, it's a different physical quantity. Okay, so we can measure it with help of two measures. What is it called as? Degree measure or radiation measure. Okay, what does this measure means? Amount of rotation. How much is the rotation, bacha? So we can measure it in two methods, either in degrees or radians. On degrees or radians, how we write it, bacha? Either degrees or radians, we write it as C. Circular. Why C, sir? Circular rotation measure. Okay, because we use here circular principle. It's called a circular measure of angles. Okay, chaliye. Let's move on to few notes that we have. Circumference of a circle of a radius 1 unit is 2 pi. Won't you agree? Sir, 2 pi r, if r is 1 unit, is 2 pi into 1 only, na sir. It means 2 pi only, na sir. Is it a problem? No, sir. Okay. Thus, one complete revolution of the initial side subtends an angle of 2 pi radians or not? 2 pi radians or not? Yes, sir. Of course. Correct, no? Basically, from here to here, if you are rotating like this, how much angle is that, bacha? This angle would be 2 pi. We also call it as 360 degrees in the degree measure. In the degree measure. Okay. Chaliye. So we call from here pi radians is equals to 22/7. Do you know these conversions? Just recalling these concepts. Okay. Please have a note of this. How can you get these notes, bacha? I hope you have joined the WhatsApp channel. If not, join it right away. You'll get this note delivered in the WhatsApp channel itself. Okay. So relation between degree and radian, we know this. If you don't want to remember all of this, just remember this. 180 degree equals to pi. That's more than enough. Pi radians, okay? Of course. Pi radians, that's more than enough. From here you get all this relation. One radian is given as 180 by pi. 180 is given as, you have to bring this over here. So 180 is given as 180 by pi, and 1 degree is given as pi by 180. For this you have to move 180 on this side. Hai na? For 1 degree you have to move this 180 on this side. Correct? They will become pi by 180. Okay? Chali. Pi by 180. Okay, let's move on to notational conventions. Again, this is the same method, bacha. Looking, if you have this value given, you're looking for this value, multiply pi by 180. If the degree measure is given, multiply like this. Same thing is written over here. Pi by 80 for the degree measure is given. Okay, you'll get the radian. Check this out. What is the unit? Radian, sir. Whenever you have a radian measure given, multiply with 180 by pi. You'll get what, bacha? Degree measure. Please check. You'll get what? Degree measure. Check this out. 180 by pi. You'll get a degree measure. Okay, this will be a degree measure, hai na? That's how you use this conversions. Okay, chaliye, let's move on. Now we have some special angles to deal with. What are those angles, bacha? We usually have 0, 30, 45, 60 and 90 degrees. Okay, again I've written only 3 ratios over here. You already know this. Right? You have 3 more. The reciprocal of sine, cos and tan. Sine will become cosec theta, cos will become sec theta, and tan will become cot theta. So is that simple? Yes. Chapter itself is very simple, no? Yes. It's actually chapter will act as a tool, bacha. Not especially the questions might come from here, but more of a tool. It will be useful a lot. You know this, right? Even the ITF is based upon trigonometric function. Calculus is based upon trigonometry and ITF. Okay, so you can see this. Lot of usefulness is there for this particular chapter. Okay. Now, so you know these values. You've learned it in grade 10, I think. Yes. But I can give you a trick to remember. I know a few of you might know the trick already. What you do is write this first row. Write the first row as 0, 1. I'll write it over here. Write the first row as, bacha, here 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. Divide everything by 4, sir. Right here by 4, by 4, by 4, by 4 and by 4. Right? Now do one thing, take roots. Root of this, root of this, root of this, root of this and root of this. Now check it out. 0 by 4, how much is that? 0. Root of that will be 0 only. 1 by 4, root is that? 1 will remain 1, 4 will become 2. 2 by 4, what is that, bacha? Will cancel. 1 by 2 will be in the denominator. So it becomes root 2. Okay, over here, sir, 3 will become root 3, 4 will become 2. So root 3 by 2. Over here, sir, 4 by 4 is 1, bacha. Root of that is 1, sir. Getting it? Once you get sine, you know sine and cos is complementary. Once you get sine and cos is complementary. 1 second. We know, sir, sine theta is nothing but cos of 90 minus theta. Correct? No? They are complementary to each other. Okay? In that case, what happens? Wherever you have the angle sum to be equal to 90 degree, you can just interchange the sine and cos values. I'll repeat. Wherever you have the sum of the two angles as 90 degree, you can just interchange the sine and cos values. Check here. 0, 90. Check here. 0 degree, 90 degree. So cos 0 is equal to sine 90. Cos 0 is 1, sine 90 is 1. Same, sir. Cos 30, angle, bacha, complementary of that, 60. So sine 60 and cos 30 is same. Root 3 by 2, root 3 by 2. Sir, cos 45 same as sin 45 because 45 plus 45 is 90. So 1 by root 2, 1 by root 2. Same here. Cos 60 and sin 30. 1 by 2, 1 by 2. Over here now, cos 90 to 0. So here we had 0, here we have 0. Complementary. Now what is about tan bacha? Sin by cos. What is tan, sir? Tan theta is sin theta by cos theta. So take the ratio. 0 by 1 is 0, 1 by 2 by root 3 by 2 is 1 by root 3, 1 by root 2 by 1 by root 2 is 1, and we have here root 3 because if you divide 2 and 2 will get cancelled. 1 by 0, sir, is infinity, so undefined. Infinity, so undefined. Okay, so we have tan. What about cosec, bacha? Simply write here. Cosec is 1 over sine. Reciprocal, you can write the respective values, na? It will become infinity, 2 root 2, 2 by root 3 and 1, right? What about sec, bacha? 1 over cos theta. So it will become 1, 2 by root 3, root 2, 2 and infinity. Okay. What about cot, bacha? It will become 1 by tan. So infinity, root 3, 1, 1 by root 3 and 0. Correct? Chaliye. Okay, so I hope this is clear. Simple only, no, very simple concept. I just wanted to explain this to you quickly and then move on to the next coming thing, which is sign of trigonometric functions. This is very important because you must have seen I keep using this a lot. Looks very simple to you, but it is very relevant, bacha. Very, very relevant. What do you do? Make 4 quadrants. Okay, quadrant 1 is this, quadrant 2 is this, quadrant 3 is here, and quadrant 4 is here. Angles, you know this very well. 0 to pi by 2, 0 to pi by 2, pi by 2 to pi. This is, bacha, 3 pi by 2, and what is this, sir? 2 pi. So first quadrant 0 to pi by 2 will be 0 to 90, basically all positive. What happens here, sir? All trigonometric ratio is positive, na, sir. Check here. First quadrant. What is the first quadrant, bacha? 0 to pi by 2 plus 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 plus. All is positive. Okay. Next, bacha, second quadrant. Pi by 2 to pi. Pi by 2 to pi. Have a look here. Pi by 2 to pi. Okay. When you check that, only sine and cosec is positive. Only sine and cosec is positive. Rest all negative. Check here. Sine and cosec. Okay, cosec here is positive. Cosec is positive in second and sine is positive in second. Because they are reciprocal to each other. Sine positive means cosec has to be positive. Reciprocal, no, sine will not change. Sine is 1 by 2. What is cosec, sir? 2. They are both positive. Okay. Chaliye. Next, sir, third quadrant. Pi 2 pi 3 pi by 2. What happens here? Only tan and cot. Tan theta and cot theta. Tan theta and cot theta. Please have a look. So third quadrant over here, if I have a look, only tan and cot. Last one, bacha, cos and sec. Cos theta and sec theta. Cos theta and sec theta. Okay. So we have cos and sec. Cos and sec positive. Please check here. Okay. So I hope this is clear. Very relevant. Very, very relevant, bacha. Third quadrant is 3 pi by 2 to, sorry, fourth quadrant is 3 pi by 2 to 2 pi. Okay. Chaliye. 270 to 360. Next, domain and range of trigonometric functions. I'll draw a few functions for you. I have already taught you this when I was teaching you ITA, but I'll still draw it. Let's see how it works out. Y equal to sin x, sir, means sine function. What happens over here? Domain, bacha, all real. Range, sir, minus 1 to 1. Make it here. Minus 1 and 1. Okay. How are you gonna solve this? Like this. Like this. That's your function. That is your sine function. What is it called as? Y equals to sin x. Y equals to sin x is the graph of, this is the graph of the function. What is the values over here? This is 0, bacha. This is going to be pi. Okay. This is going to be, excuse me. Oh, this is not sin x, right? Yes, this is not sin x, sir. This is cos x, bacha. Forgive me. I drew cos x. You know, I wanted to draw actually sine, but I drew cos x by mistake. My bad. Let me draw the sign now. So it'll be like this, bacha, actually. Okay, it'll be like this. Please have a look. So it'll be, bacha, here. Peak will be at pi by 2. You'll have pi over here. You'll have 3 pi by 2 over here. And you'll have 2 pi over here. So you can see this. This point will again, this point, if I mark it over here, this particular point is going to repeat after this point. Means the repetition will come after 2 pi. That's why they're saying sin x repeats after interval of 2 pi. After interval of 2 pi. Okay. So range is going to be what, bacha? Minus 1 to 1. This is going to be, sir, minus 1. This is going to be, sir, plus 1. Okay. So minus 1 to 1. Okay. Chali. This is your domain and range. I hope this is clear. All right. Please check. Simple graph, very simple, not difficult. After doing so much of PU2 preparation, graphs and all, this looks very simple. It is simple. Okay, great. So this is clear. Moving on to cos x. I drew the graph of cos x already. I'll just draw the same thing over here. So cos x will look like this. Okay. Okay. This is negative of x, this is going to be plus x. Okay, this is y, this is y dash or negative y, whatever you want to call. Over here, bacha, 0. Here I have, sir, pi by 2. Here I have, sir, pi. Here I have, sir, 3 pi by 2. Here I have, sir, 2 pi. Okay, this is 2 pi, sir. This is 2 pi. Clear now? Alright, sir. What is that going to be? Minus pi by 2. And this is, sir, minus pi. This is minus pi. Please check. Please check. Okay. So what we are getting over here, sir? We are getting, again, you can see this point. This point over here. This peak over here will repeat after this. So again, this is coming after how many parts? 0 to 2 pi, no? So again, the cos x repeats after interval of 2 pi. Means same graph will repeat. After this, what will happen? I'll cut this off and again start from here. Correct na? Same over here. This will, bacha, is going to be repeating from here to here. Please check. Please check. Cos x, the periodicity is, this is going to be periodic in 2 pi. Periodic in the interval of 2 pi. Clear? That's what the meaning of the repeat, What is the meaning of repetition? Periodicity, okay? So please check. This is done. Moving on to tan x. Chali. So we'll draw this. We have, bacha, the domain and range, right, over here. The domain is, bacha, all real, range is also same. Minus 1 to 1. This is, bacha, my plus 1, this part. This is going to be, this part is going to be, sir, minus 1, okay? So minus 1 to 1. Range is minus 1 to 1. Okay. What about this, bacha? So I'll have, check this out. Very interesting. Okay. Okay. Again, you'll have, bacha, this. Okay. This side also you'll have like this only. It'll continue like this. Please check. Okay. Over here as well. If you want, you can draw it like this. Over here as well. There's going to be, now what are the intervals? What are the values over here? This is, sir, 0. This is going to be, sir, pi by 2. This is going to be, sir, pi. 3 pi by 2. Okay. And this is going to be, sir, 2 pi. Okay. And like that. Okay. Now you can see the repetition is coming, bacha, after pi only. How come, sir? Please have a look. This part repeat after pi only. Repeats after pi only. That's why periodicity is in the interval of only pi. It's periodic in the interval of pi. What is the period, bacha? The period is pi, sir. Period is pi. Okay, what happens at this point is not going to be like this. It's going to be like this, okay? It's going to be non-touching. It will never touch. So 1 second, I will just make this change a little bit. This will not be like this. Okay, I can draw it again. Let me make it better. It should be like this, bacha. Okay, it will never touch. It will never touch. So at pi by 2, the function is not defined. Function is undefined. We know this now. We're getting this value as infinity. This is, bacha, y equal to tan x. See, in the domain you don't have odd multiples of pi by 2. 2n plus 1, sir. 2n plus 1 is odd number, no? 2n plus 1 is odd number. 2n is an even number. Plus 1 means odd number. So at odd multiples of pi by 2, what is there? What it means? Odd multiples of pi by 2, tan x is undefined. Is undefined. Okay? Infinity basically. Please have a look. Okay, I hope this is clear. Now the last three. Cot bacha is basically reciprocal of tan, comes like this. In reverse bacha, over here we at pi by 2 and at multiple of pi by 2 it was undefined. Now it becomes 0 over here. Please check. It becomes 0 over here. What is the meaning of undefined, sir? It's going to be 1 by 0, no? If you take reciprocal, it will become 0 by 1, right? Yes. So basically what you're going to get, check this out, 0, na? So at odd multiple of pi by 2, 0 bacha. And wherever it was 0, it becomes infinity. See, at 0 it was, at tan equal to 0, sorry, at x equal to 0, at x equal to 0, the tan was bacha what? Tan was 0. Over here what is cot? Infinity. Check this out. So what happens is, at the even multiples of pi by 2, which where the tan was 0, cot is infinity. Why, sir? Because tan and cot are reciprocal to each other. Because tan and cot, so we have cot x is basically equal to 1 by tan x. So wherever tan x was equal to 0, what happened to bacha cot? 1 second. Whenever tan x was equal to 0, what happened to cot x? It became infinity. And whenever tan x was actually equal to infinity or going to infinity, we'll say cot x is becoming equal to 0. That's why at odd multiples, in the case of tan, odd multiples, it is coming bacha infinity. Check here. Pi by 2, 3 pi by 2, 5 pi by 2 here, sir, minus pi by 2, okay, like that. Okay, at odd multiples of pi by 2, it is becoming infinity. But in this case, at odd multiples of pi by 2, it's becoming 0. Whereas, at the even multiples, basically 0, pi, 2 pi like that, what happened, bacha? It is becoming 0 in the case of tan. Over here, what we have, in the case of cot, it's becoming infinity. See, 0 at infinity, at pi it is again infinity, at 2 pi again it's infinity, at minus 2 pi again infinity. So making relevance. Okay, this is clear. What is the periodic, bacha? The periodicity again is in the interval of pi only. Okay, so what's the period here? Period is again pi, bacha. Please check. This part repeats after pi by 2 to 3 pi by 2. What's the difference over here? Pi only, no? Difference is pi only. Clear? Okay. Chaliye. Now we are going to cosec x. What is this going to be? Cosec x is, bacha, reciprocal of sine. So since sine was having a range of minus 1 to 1, so what will happen to the cosec, bacha? It will start from 1 and go to infinity, from 1 to infinity from here, and from negative infinity to 1, from negative infinity to minus 1. Right, now for sine what we had? Minus 1 to 1, no? For sine, right? What happened to cosec? Reciprocal of that. It became negative infinity to 1 and, sorry, minus 1 and 1 to infinity. Okay, the graph is like this. Please check. Just the ulta graph. It was like this, no? Remember this? That's the curve. That was the curve. I'll show you for the sine. This was the curve, right? For sine. That's why ulta, reciprocal. Over here as well. This was the curve, right? It became reciprocal. Clear now? So points will remain same. Wherever it is pi by 2. So wherever it was 0, now it will become infinity. That's why. See, sine 0 was 0. What happened to cos? So what happened to cosec? It has become infinity, bacha. It will never be equal to any value. It's undefined. Sine 0 is 0 means 1 by sine 0, sir. Will be 0 only. No, so 1 by 0 becomes infinity, right? So that's why undefined. Okay? That's why undefined, sir. I want to just erase this. Okay. So I hope this makes sense to you. What's the period, bacha? Period remains same. 2 pi only. Sine and cosec will have same period. Okay? Let's move on to now sec. Okay? Again, same thing happens. The case of cos. Exact same as cos. What happens here? In sec x, 1 by cos x. What happens here? Please check. It was minus 1 to 1. Same thing is over here. If you remember the graph, I can show you in this case as well. The graph was like this. Right? The graph was like this. Correct, na? For cos, what is this going to be? Y equal to cos x. That's why reciprocal is the blue line. The blue line is the reciprocal, sec x. Please check. Again, the period remains same. The period remains again 2 pi only. Periodicity is again 2 pi. It repeats. This point is coming from 0 to pi. This point here, please check. This point here is coming after 2 pi, 0 to 2 pi. The repetition comes after 2 pi, interval of 2 pi. Moving on to some important formulas and some functions. Let's see operations we'll have. Trigonometric functions of sum and difference. This is just sum actually. sum and difference of two angles. Sin of minus x bacha is going to be minus sin x, odd function. Okay, cos of minus x is going to be bacha cos x, even function. Over here bacha whenever you have 90 minus theta, whether it is sine, cos, anything, 90 minus theta we have, it remains, sine will become bacha cos, okay, and angle will remain same. Check this out. How, sir? So I'll show you, sine will become cos and cos will become sine. You also have tan will become cot will become tan, and you'll have bacha sec will become cosec, and cosec will become sec. When sir, whenever you have add odd multiples of pi by 2. Basically it means pi by 2, 3 pi by 2 and so on, 5 by 2 and so on, 5 pi by 2 and so on. Okay, so whenever you are dealing with odd multiple, so 90 is odd multiple of pi by 2, 90, okay, so 1 is there, no, 1 into 90, odd multiple, right? So whenever you have that, what happens? It will change. Sine will change to cos, cos will become sine, tan will become cot, cot will become tan, like this, please check. Cos becomes sine, sine becomes cos. Here bacha, again, cos becomes sine, sine becomes cos. Here sir, doesn't change. Wow bacha, pi is even multiple of pi by 2, no? Pi by 2 into 2, how much is that? Pi. How much is that? Pi. What is it going to be? Even or odd? Even, sir. So pi is even multiple of pi by 2. Pi is even multiple of pi by 2. Check it right here. At even multiple of pi by 2, the trigonometric function does not change or remains same. Remains same, sir. Remains same, sir. Okay, the function will not change. So check here, cos becomes cos, sine is sine, cos is cos. So there is a plus and minus sign, sir. There is a plus and minus sign. Check it out. Which quadrant bacha angle is in which quadrant? 90 minus x. Which quadrant bacha? First quadrant. Sine is, cos is positive or negative in first quadrant? Sir, first quadrant all is positive, na? Sir, first quadrant all. Second quadrant is sine and cosec. This is sir tan and cot. This is sir cos and sec, sir. Check this out. First quadrant, cos becomes sine and sine is positive. Bacha, this angle pi by 2 minus x. Again first quadrant, pi by 2 minus x. First quadrant, sine becomes cos because of odd multiple and positive. Right? 90 minus x, no? First quadrant. Angle is first quadrant and sine becomes cos because of odd multiple of pi by 2. Okay? Over here, what is it going to be, sir? Again, odd multiple pi by 2. Cos becomes sine. What angle, sir? Where is this angle? Pi by 2 plus x. Pi by 2 plus x is in second quadrant. Pi by 2 plus x, sir. Where, bacha? Second quadrant. Pi by 2 is 90 plus some angle. Which quadrant? Second quadrant. I'll repeat. Pi by 2 plus x, second quadrant. What is going to be the operation? Only sine and cos is positive. What is it we are having here? Cos. Sine and cosec is positive, not cos. Second quadrant, sine and cosec is positive. Sine and cosec is positive. It means, sir, cos will become negative. Sir, cos at pi by 2 becomes sine. Cos at pi by 2, odd multiples of pi by 2. Cos at pi by 2 becomes sine. Cos becomes sine. Okay, negative because cos is negative in second quadrant. I'll repeat, cos becomes sine because at pi by 2 it will change to sine, and negative because second quadrant. Cos is not positive in second quadrant. Sine is positive in second quadrant, right? Sine is positive, not cos. Sine is positive. That's why cos is becoming minus sine. Here, sir, sine pi by 2 plus x. Sine pi by 2 plus x. Which quadrant, sir? Second quadrant, sir. So sine will become cos. First of all, sine becomes cos. How come, sir? Odd multiples of pi by 2, na, sir? Means sine will change to cos. Okay, sine becomes cos. Angle is positive, sir. How come, bacha? Second quadrant, sine is positive. Second quadrant, sine is positive. Okay. Next, bacha, cos pi minus x. Sir, cos will remain cos. Cos will remain cos. Why, sir? Pi, even multiple of x. Sorry, even multiple of pi by 2. Pi is even multiple. Pi is even multiple. What happens even multiple? Even multiple, function remains same. Even multiple, functions remain same. So cos remains cos. Cos remains cos. Angles are negative. Why, sir? Pi minus x. Pi is this value, no? Pi is this, sir. Pi minus x, bacha, second quadrant still. Pi plus x, third quadrant. Pi minus x, second quadrant. Check here. Pi minus x, you will go like this only, no? Which quadrant, bacha? Second quadrant. Second quadrant means cos is negative, only sine is positive. Second quadrant, cos is negative, that's why minus cos. Cos remain cos because of the even multiple of pi by 2, negative because of second quadrant. Here bacha, sine pi minus x. What happens bacha? Even multiple of pi by 2. Sine remains sine, pi minus x is the second quadrant angle, hence positive. Getting my point or not? Let me know in the comment section of this video that you got this part. Okay? Chaliye. Again bacha, cos pi plus x. Pi, even multiple of pi by 2. Pi is even multiple of pi by 2. Pi is even multiple of pi by 2. What happens? Function does not change. Even multiple, trigonometric function does not change. Trigonometric function does not change. Cos remain cos. Cos remain cos. Angle bacha negative. Why bacha? Angle here sir, pi plus x. Over here third quadrant na. Pi plus x, you'll go like this. Third quadrant. Cos is negative in third quadrant. That's why negative. Getting it or not? Getting it or not? Yes. Okay. Let me know in the comment section you got it. Okay. I hope I have not confused you a bit. Chaliye. Pi plus x. Sine pi plus x. Again draw the quadrant. Pi plus x. Pi sir even multiple. Sine will remain sine. Plus x means third quadrant. Sine is negative here. That's why minus sine. 2 pi minus x. 2 pi is even or odd multiple of pi by 2 sir. Even multiple sir. Think about it. Pi by 2 into 4 is how much sir? 2 pi na sir. Pi by 2 into 4 is 2 pi na sir. Correct? Is 4 even or odd sir? Even multiple. So sine will remain sine sir. Sine will remain sine sir. Why negative sir? Which quadrant is this angle bacha? Fourth quadrant. 2 pi is here na bacha. Minus x means this quadrant. Right? 2 pi minus x means fourth quadrant. Fourth quadrant, sine is negative. Only cos and sec is positive. Only cos and sec is positive. Sine is negative here. It means negative sine. We're not talking about this sign. We're talking about this sign. Okay? Very important. Don't look at the result function. Don't look at resulting function. Look at the operating function. Okay? Excuse me. Over here also, operating function is cos. 2 pi remains cos. Which quadrant bacha? Fourth quadrant. Which quadrant bacha? Fourth quadrant. Fourth quadrant cos is positive. Fourth quadrant cos is positive. Hence positive. Hence positive. This part is clear. I said angles is very important to know where the ratios are positive. I hope you got this. Chali. Now we have some formulas we have to deal with. We'll see the formulas quickly. You don't have to worry too much about it because you have to remember the formulas anyway. That's why this chapter's formulas is very, very relevant, bacha. You can see these questions coming in, differential equations coming in, integration, everywhere. These questions will be coming. So you have to remember all the formulas without fail. Okay? Chali. First one, cos a plus b, cos x plus y, cos x, cos y minus sin x, sin y. Remember this for property. Whenever you have plus, no, it will become sine. In case of cos, it remains same, bacha. Cos and cos, sine and sine. Whenever it is minus, bacha, it will become plus. That's how I remember. If it is minus, it will become plus. So, and this will remain same, cos and cos. Cos and cos, sine and sine. What about this, bacha? Sine x plus y, it will become sine cos with a plus sign. Sine cos with a plus sign. When it is minus, bacha, it will become sine and cos with negative sign. Change the angle. X, y, change between sine and cos. Sine x, cos y, cos x, sine y. Over here, bacha, tan x plus y, bacha, this will be plus over here and this will be minus over here. When it is minus, bacha, it will become minus and plus. Just ulta. If it is plus means it will become minus. So it will be minus so plus, plus so minus. Denominator I'm talking about. This is same. This is same, sir. Tan of x plus y will be simply tan x plus tan y upon 1 minus tan x tan y. This is, if this is minus, this will become minus, this becomes plus. I've used this formula multiple occasions. Okay, chaliye. Have a look over here. Same goes with cot. Cot is going to be reciprocal, so it will be cot x cot y minus 1 upon cot y plus cot x. So here plus means here minus. Okay, here minus means here plus. Okay, chaliye. So relevance is there. Please check the formulas and remember it. Cos 2x, bacha, you use these formulas a lot of times. All this is very, very important. Very, very, very important, bacha. These formulas are very relevant. Cos 2x is cos square x minus sin square x, which is nothing but 2 cos square x minus 1. How come, sir? Convert sin square into cos square, you're going to get 2 cos square. Right? Here, bacha, you're going to get, convert cos square into sin, it will become 1 minus 2 sin square. And also, if you have to write cos 2x into this, sometimes this is also relevant in the questions in integration. It is, it has been. I've solved this kind of questions with you. what happens is, remember the question tan inverse of root x, that question. Okay, so what happens here is 1 minus tan square x upon 1 plus tan square x. This also is the same formula for cos 2x. Okay, if you have this, check this out. Sin 2x bacha, it'll become 2 sin x cos x. We know this formula. This also is very, very important. Do one thing, divide this and this. Divide this and this. Sin by cos. What will happen? Sin 2x by cos 2x. Okay. What is that going to be? 2 tan x upon 1 plus tan square x, and this is going to be 1 minus tan square x upon 1 plus tan square x. This and this is cancelled. What is the result? 2 tan x upon 1 minus tan square x. This formula for tan. Sin by cos bacha is going to be tan 2x equals to 2 tan x upon 1 minus tan square x. Relevant? Okay, chaliye, please check. Relevant, sir, over here. This makes sense to you? Okay. Acha, sir, is there a derivation for these formulas? Yes, there is a derivation for these formulas, but not relevant to you. It will not be helpful to you. Okay, you are solving objective questions here. They never ask the derivations, so why doing all of that effort? Okay, just remember the formula. That's more than enough. Knowing the formula is more than enough for you. Okay, but yes, derivation is there. Derivation is there, but you use circle to get these results. Okay, chaliye. Sin 3x is bacha this formula, again relevant. I've solved questions like this in ITF, I think. Yeah, 3 sin x minus 4 sin cube x, and for cos 3x we have 4 cos cube x minus 3 cos x. Tan 3x bacha, this very rarely used, but remember this formula as well. This for the first 1, 2, 3, 4, 5 formulas are very, very important. Last one is rarely used, but still you remember this. 3 tan x minus 3 tan cube x upon 1 minus 3 tan square x. Okay, you can also find this formula using tan x plus 2x. Okay, let's get ahead. This is done. Now, sir, very important. This also is very, very important. Not for the chapters. Usually they don't ask these based questions in PU2 chapters, but for trigonometric function they ask these questions. You can see the questions right now. I've taken one question like this. They ask this question based upon this. Okay, so have a look. Cos x plus cos y is 2 cos of x plus y by 2 and cos of x minus y by 2. Whenever you have plus over here, it is going to be, first of all, whenever you cos, but it will become cos and cos only. Okay, so whenever it's plus sign, it will become cos and cos. If you have minus sign, it will become sin and sin. Understand this. Whenever you have cos and cos, two formulas are there, no? Cos a plus b, cos a plus cos b, or cos a minus cos b. Whenever you have that, with plus it will become cos and cos, with minus it will become sin and cos. Sorry, sin and sin. Okay, this will remain same, x plus y by 2 and x minus y by 2. Okay, there's a minus sign in this case. There's a minus sign in this case. Okay, chaliye, over here, sin x plus sin y, sin x plus sin y. Okay, if you don't want to write this minus, now what you can do is write over here y minus x. Write this as y minus x by 2. Don't have to write the sign negative over here. Your choice. Okay, or if you want to keep this without any change, keep a minus sign over here. Very important. Okay. Sin plus, whenever you have sin and sin, you will get bacha both sin and cos. If it is plus, it will become simply 2 sin a plus b by 2 and sin cos a minus b by 2. I have taken as a plus b and a minus b. In this case, I have taken here x and y. You can take anything, that's not relevant. Here, whenever minus sign, you can get 2 cos and sin. So, sin is operating on x plus y, here cos will operate on x plus y. I know this formula is a little difficult to remember, but you have to remember anyway. Okay, chaliye. Now let's move on to some few that we are having. 2 cos x cos y will become equal to cos x plus y times of cos of x minus y. Actually, this formula can be derived using this also. Okay, but we don't have derivation right now. We'll just quickly revise the formulas and solve some questions. Okay, again over here, bacha, minus 2 sin x sin y. Can you see the relevant over here? The relevance: 2 sin sin, 2 sin sin, 2 sin sin, cos minus cos, cos minus cos. So basically what I'm trying to say here is, you substitute a equals to x plus y and b equals to x minus y. This is what is going to be x a plus b by 2, a by 2 and b by 2, a by 2 and b by 2. Please check. Okay, so you're going to be a plus b by 2. What is this going to be? A plus b by 2, and it will become a minus b by 2. Check here now. Right, sir. A plus b by 2. How much bacha? How much is that going to be? X plus y plus x minus y. How much is that? Y cancels. By 2 I'm asking. So 2x by 2, how much is that? Simply x. Check this out. What is going to be? Sine of a plus b by 2. Sine of a plus b by 2. Yes or no? Right? Confusing? Don't worry about this. I know you might know this, but if you don't know, it's okay. Just remember the formula, that's more than enough. Okay? 2 sine cos y is sine a plus b, or sine x plus y plus sine x minus y. 2 cos sine y, sine x plus y minus sine x minus y. Okay? Chaliye. Now questions, bacha. I'll take some questions, solve it quickly, and then wrap up this particular session on trigonometric function. I know it has been fast, but we are having a little crunch of time, and small chapter, not that difficult. Yes, formulas are difficult to understand, some formulas, but you can spend some time on that by practicing more and more questions, and you'll get good at that. Okay, so let's solve the first question. We have sine theta equals to sine 15 plus sine 45. Okay, find the value of the theta value. Okay, we find the theta value. Chaliye. So sir, this is going to be sine theta equals to sine a plus sine b. Okay, it will become 2 times of sine of 15 plus 45 by 2. Okay, into cos of 15 minus 45 by 2. That's the formula, right? Sine a plus sine b. Please check. Sine a plus sine b. This one. 2 sin a plus b by 2 and cos a minus b by 2, है ना? 2 sin a plus b by 2 and cos a minus b by 2. Check this out. It will become 2 times of sin 60 by 2, sin 30 degrees, 45 plus 50, 60 by 2, okay, 30 degree. Over here बच्चा cos of minus 15 will become 15 minus 45 is minus 30 by 2 is minus 15. Okay. Check this out. It will become 2 times of 1 by 2 into it will become cos of 15 only, no sir, not change. Cos of minus theta is cos theta, no, we just learnt it. Okay, even function. This cancels, bacha. What I'm getting here, this is sin theta, no, so sin theta equals to cos 15, right? I can write this as cos of 90 minus 75, correct na? 15 is what, bacha? 15 is going to be 90 minus 75. 15 is 90 minus 75, sir. This angle 15 is 90 by 75. Okay, cos at 90 will become sine. Which quadrant, bacha? First quadrant, means positive. Compare now. Sin theta is 75, means theta is 75 degrees. Option number D is correct. Please check. Good question. Right, I said no, not relevant to other chapters, but in functions it becomes relevant with these formulas that I've given list of. Okay, moving on to question number 2, the value of 4 sin a cos cube a minus 4 cos a sin cube a based upon the identities that we have. Okay, let's do one thing, take 4 sin a cos a and 4 cos a sin, basically same thing. So take 4 sin a cos a common, sir. What happens here is I've left with cos square a minus here bacha sin square a. You know the formula now. Do one thing, break this as 2 times of 2 sin a cos a, the first one, and next one bacha this part. What is it going to be? Simply cos 2a. Right now, cos 2 minus sin square. Cos 2 minus sin square is cos 2a. Okay, great. What about this? Keep 2 as it is. It will become bacha 2 sin a cos a will becomes sin 2a and it will become cos 2a. Check the formula. 2 sin 2a cos 2a. So sin 4a. Sin 4a. Option number D is correct. Please check. Simple question. Very simple. Okay. Question number 3 now. The value of root 3 cosec 20 minus sec 20 is. Good question. This is a very good question. Let's solve it. So root 3 is cosec 20 and so let's convert it into sin and cos. Root 3 by sin 20 degrees minus 1 by cos 20 degrees. Why bacha? Because formulas are there for sin and cos. That's why. Take LCM now. Sin 20 into cos 20. I get here bacha root 3 cos 20 minus sin 20. Okay. If I had 2 over here, it will become bacha formula 2 sin a cos b. Multiplying 2 means multiply 2 over here. Okay. So I get so far like this only. Let's keep it like this only. Okay. I get here bacha 2 outside. Okay. And one more thing I'm going to do. Multiply 2 over here. And in the bracket I'll multiply everything with 2. Divide everything by 2. It will become root 3 by 2 cos 20 minus sin 20 degrees by 2. Please check this out. Divided by what I have, sin 40. Please check this out. 2 sin 20 cos 20, so sin 40. Sin 220 na, 2 into 20, sin 40, that I have. Now what I've done here, no, I multiplied this 2 outside and divided here by 2. So if you cancel, it'll become again root 3 and sin 20, okay. Why I did that, I'll show you. I'm going to club this together, it'll become 4. It'll become 4. What I have now is 4 times of root 3 by 2, bacha. What it is going to be? What is going to be? Sin 60 cos 20. Now write this as minus 1 by 2 into sin 20 degree and divided by sin 40. 40. Close the bracket. What I'm getting over here, check 4 as it is. It'll become bacha sin 60 cos 20 minus 1 by 2, sir. So cos 60 and sin 20 divided by sin 40 degrees. Please check now. I'll keep this as 4 only. What I get? Sin A cos B cos A sin B. Sin A cos B cos A sin B. Sin A minus B, sir. Sin of A minus B, sir, divided by sin 40 as it is. Okay. This is the same thing. Sin 60 minus 20 is sin 40 only, no? What is the answer, bacha? 4 into 1, simply 4. Okay. The steps are like this. Please check. Answer is option number D. Please check. Please have a look. This is clear. Have a look, not a problem. Yes. Okay. Moving on now to question number 4. If A plus B is 5 pi by 4, then find the value of that 1 plus tan A times of 1 plus tan B. Have a look. A plus B, I'm on tan, right? I'm on tan A tan B. Let's do one thing. Apply here, sir. A plus B is 5 pi by 4. Apply tan on both sides. So tan of A plus B becomes equals to tan of 5 pi by 4. I can do that. Okay, this will become bacha tan A, we learn this formula, tan B upon 1 minus tan A tan B. What about this bacha? It will become tan of pi plus pi by 4. Check this out. It will become, sir, tan at pi. Tan at pi. At pi means bacha at even multiple of pi by 2. Remains tan only. Remains tan only. So tan pi by 4. What about angle, bacha? What about angle, sir? Tan, which quadrant is this? Pi plus pi by 4. Third quadrant. This is pi plus pi by 4, bacha. Third quadrant. Okay. So positive, no? Tan is positive in third quadrant. Okay. Please check what I'm getting here. 1 equals to this value. Tan A plus tan B divided by 1A, 1 minus tan A into tan B. Cross multiply now. Cross multiply now. What I'm getting? Tan A plus tan B equals to, cross multiply, 1, this whole thing into 1 will remain as it is, 1 minus tan A into tan B. Bring this term on this side, it becomes bacha tan A plus tan B plus tan A into tan B equals to 1. Now do one thing. I already have, I have tan A. I can just multiply, I can just add on 1 over here. So let's do one thing. Add here 1, 1 plus, here also plus 1. This extra part, okay? I'm adding this 1 on both sides. This 1 plus and this 1 plus is extra. What happens here? Club this together. 1 plus tan A, keep it together. Over here, take tan B common. So if I take tan B common, what is left in the first part? 1 is left. Over here, sir, tan A is left. What about this? 2, sir. 1 plus 1 is 2. Now this is common, no? 1 plus tan A, 1 plus tan A is common. So take that out. 1 plus tan A is common. What's left in the first term? I have nothing left, no? So 1 is left. What about this term? So tan B is left. We are looking for this value only, no? What is the answer going to be? 2, sir. This is my answer. Please check. Answer is 2, sir. Answer is 2, sir. Please check. I hope this is okay. Good. Had fun. Moving on to question number 5. Please check. Okay. Tan a minus b equals to 1. Sec of a plus b equals to 2 by root 3. Okay. Good question. Tan of a minus b is 1. So it means bacha a minus b can be 45 degrees. Okay. Or it can be bacha actually third quadrant na. Tan is positive where bacha? Check here. Quadrant rule. Tan is positive, sir. Tan is positive here or here. Tan, sir, here or there. It means either 45 or what is it going to be? This is going to be 180 plus 45, no? So I can write like this. 45 is what, bacha? Is going to be basically pi by 4 or sir pi plus pi by 4, no? Same value. How much is that going to be? 5 pi by 4. How come, sir? Think about it. We just learned, right? Over here we saw tan of pi plus pi by 4. How much is that, bacha? Tan pi by 4. How much is that, bacha? 1. Tan of pi plus pi by 4 is tan pi by 4, nothing but 1. Okay? It means for 1, when tan is equal to 1, I can have two values, either pi by 4 or 5 pi by 4. Agreed? Yes. Let's look at same thing for sec. For sec, bacha, we have a plus b equals to 2 by root 3. So we know this for sure that a plus b has to be pi by 6, 30 degrees. Cos 30 is root 3 by 2. So sec will be 2 by root 3. So pi by 6. Is it more than enough? Sir, cos is positive, bacha, here and here, sir. First and last quadrant. First and fourth quadrant means either this or 2 pi minus pi by 6. How come? I can go like this also, no? An angle going like this, I can go like this also. Okay, how much is that going to be? 2 pi minus pi by 6. That's, sir, 11 pi by 6. Okay. So we have the values now, a minus b and a plus b. Let's write it over here. I'll write it like this. A plus b equals to 11 pi by 6 and a minus b equals to 5 pi by 4. Subtract, sir, sign change, difference will be minus plus minus. This cancels out, I get b plus b, so 2b. I'm looking for b only, so that's good. It'll become 11 pi by 6 minus 5 pi by 4. Okay. What I have? 2b equals to 11 pi by 6 minus 5 pi by 4. LCM, sir? 12. LCM is 12. So 22 pi minus 4 3s are. So 15 pi. Hai na? You can do the calculation from your side also if you're not getting it. Okay. So 7 pi by 12 equals to 2b. Hence, b equals to 7 pi by 24. Bring this 2 on this side. So 2 into 12 will be 24. Option like this. Please check. Yeah, option D. So option D is correct. Please check. Have a look. Question number okay, no, sorry. Yeah. So question number 5, we have bacha answer as option number D. Please have a look. This is clear. This about. Okay. So this completes bacha the session number 1 for trigonometric function, where we have done almost all the concept formulas. I've given the list of it. Please go through it. Anything else you want from this chapter from me, let me know in the comment section. Okay, I've tried to give you confidence in graphs and everything has been discussed. Questions also we have solved some. We'll solve more questions coming in your next session. Till then, you have to keep working hard, keep solving more and more problems. Take care of yourself. Bye bye.